In this video, we will look at two examples of the quotient property for exponents. Example 1, we want to simplify the quotient of 5x to the 5th y to the 7th over 15xy cubed. Okay, so I'm going to do this in two ways. The first way, I am going to write out every exponential expression as repeated multiplication. So here's what I mean. In the numerator, 5x to the 5th y to the 7th, I'm going to write that 5, and then I'm going to write 5 factors of x and 7 factors of y. Okay, good. They all fit. Then I have my fraction bar. Now, in the denominator, I'm also going to write 15 as the factors of 5 and 3. You'll see why I did that in just a minute. And then I have 1 factor of x, and then I have 3 factors of y. The reason why I wrote this out as repeated factors is because now I can divide out the common factors that I see in the numerator and the denominator. So I'll notice 5s are common. So I can do 5 divided by 5, and that just leaves 1 behind. So 5 divided by 5 is just 1. So I can divide out the common factor of 5. There's no 3 in the numerator, so now I'm going to move on to the x's. Well, there's 1 factor of x in the denominator, so I can divide out 1 factor of x in the numerator. Since there's no more x's in the denominator, now I move on to the y's. So for every 1 y in the numerator, I can divide out 1 y in the denominator. So there's 1 common factor of y, there's another common factor of y, and there's another. So I can divide out a total of 3 factors of y. Let's look at what we have remaining. In the numerator, I have 4 factors of x and 4 factors of y, and in the denominator, I have the 3. So let's simplify now. So in the numerator, I had 4 factors of x, which becomes x to the 4th, and then 4 factors of y becomes y to the 4th, and then that becomes over my denominator, which is just 3. So that's one way of doing it, where you write everything out as repeated factors and then you divide out the common factors between the numerator and the denominator. Let me give myself some new space to work, and I'm going to show you the way we would use it, or the way we would do this problem using the rule in the gray box at the top of the screen. So there's 2 versions of the rule. So I'm going to kind of split this up. I'm going to have the numbers 5 over 15, and then I'm going to have the x's where it was x to the 5th over x to the 1st. So if you notice, I put in the exponent of 1 for the x in the denominator, and then I circled the version of the rule that we're going to use. So notice when your m exponent is greater than your n exponent. That means when the exponent in your numerator is greater than the exponent in your denominator. And make sure you're looking at the same base. So we're looking at the bases of x. So the numerator, or the x in the numerator, has a greater exponent than the x in the denominator. So I'm using the m greater than n. So that tells me to take the numerator exponent, which is 5, and subtract the denominator exponent, which is 1. So this becomes x to the 5 minus 1 power. And then I'm going to do the same thing for the y's. Since the exponent in the numerator for the y, which is the 7, is greater than the exponent in the numerator, which is 3, I'm going to do y to the 7 minus 3 power. So now let's clean this up. 5 over 15 is 1/3. X to the 5 minus 1 power becomes x to the 4th, and I'm going to put that over 1 because x to the 4th is in the numerator, so I want to show that there's a 1 in the denominator. So when I make my final answer, I keep my numerators and my denominator separate. And then I get y to the 4th power over 1. And now I multiply my numerators and my denominators straight across. So my numerator becomes x to the 4th, y to the 4th, and my denominator is 3 times 1 times 1, which is just 3. So you can see no matter which way we approach this problem, we arrive at the same answer. X to the 4th, y to the 4th over 3. Let's take a look at example 2. I'm going to start by expanding everything in the numerator and writing it as repeated factors. I'm going to start with 10 as 5 times 2. Hopefully you can see why I did that. Hint, hint, there's a 2 in the denominator. And then x to the 3rd is 3 factors of x, and y to the 3rd is 3 factors of y. In my denominator, I have 2 times 6 factors of x, and then 7 factors of y. Let me just expand my fraction bar. Okay, now I'm going to divide out common factors. So the 2's are in common. And then for every x in the numerator, I can divide out 1 x in the denominator. So that means I can divide out 3 common factors of x. Same thing for the y's. I see that there's 3 common factors of y. Now let's look at what's left over. In the numerator, we just have a 5. In the denominator, I have x times x times x, which will become x cubed. And I also have 4 factors of y, which will become y to the 4th. So I have 5 over x cubed y to the 4th. Let's take a look at it using the rule. Well, now I'm going to use the rule where n is greater than m. So that means when my denominator exponent was greater than my numerator exponent. So I'm going to start with the 10 over 2 like I did in the last problem. But now my rule tells me it's 1 over, and then I have the base, but then I take the denominator exponent and I minus the numerator because the denominator exponent is now larger than the numerator exponent. So when your exponent in your denominator is larger than your exponent in your numerator, the leftover variables, that means the variables that did not divide out, are now in the denominator. So look what happens here. This becomes 1 over x to the 6 minus 3 power times 1 over y to the 7 minus 3 power. And again, the reason why they're in the denominator now is because the base that had the greater exponent was in the denominator. So those leftover x's and y's ended up in the denominator because I couldn't divide them out. So now 10 over 2 becomes 5 over 1. And then I have 1 over x cubed times 1 over y to the 4th. And now if I multiply those together in my numerator, 5 times 1 is 5, and then 1 times x cubed y to the 4th. So you can see, again, I get the same answer no matter which way I approach the problem.